In our last example for Bayes' rule here, we've got a family that has 3 children, and we're given that there are no twins. We're given that there are at least 2 girls, and we want to find the probability that the oldest child of those 3 children, is a girl. So again, let me set up some events here. We're asked the probability that the oldest child is a girl. So let me set up an event B1 is the event that the oldest child is a girl, and that oldest child could also be a boy. I'll call that B2 is a boy. Overlapping both of those is the event that we're given. We're given that there are at least 2 girls. So my event A will be that there are at least 2 girls. So let me draw a map of this experiment. These B1 and B2, those are disjoint events because that oldest child either is a boy or a girl. So there's B1 and there's B2. But overlapping both of those is the possibility that at least 2 of them could be a girl. So that's my A. And we're given that A is true, and we want to find the probability that the oldest child is a girl. So we want to find the probability of B1 given that A is true, given that at least 2 of the children are girls. And we have a formula for that we have 2 events here. So this is really using Bayes' rule for 2 events. And let me expand out that formula. According to the second slide of this lecture, you can just page back and find it if you don't remember it. It's P of A given B1. You just switch those around, times P of B1. And then the denominator is that same expression. So let me copy that again. P of A given B1 times P of B1. Plus the same thing with B2. A given B2 times the probability of B2. So now we have to figure out all those probabilities and drop them into the formula and calculate it out. The probability of B1 is fairly easy. That's the probability that the oldest child is a girl. That's 1/2. So we can fill that in. The probability that the oldest child is a boy is also 1/2. That's at least if you have no extra information about that. But now the probability of A given B1 and A given B2 are a little trickier. So let me calculate out those down here. The probability of A given B1. So that means that we're given that the oldest child is a girl. We're given that the first child is a girl. And we want to figure out the probability that at least 2 children are girls. So the probability that at least 2 children are girls, if the first child is a girl, means the probability that at least 1 of the younger 2 children, is a girl. And so we've got 2 younger children here. So the 2 younger children could be girl-boy, could be girl-girl, could be boy-girl, and it could be boy-boy. And at least one of them being a girl, there's 3 of those situations where at least one of them is a girl, so that's 3/4. The probability of A given B2, we're going to need to fill that in. That's the probability of at least 2 girls given that the oldest child is a boy. So the probability that, well, if the oldest child is a boy, then to get at least 2 girls, you've got to have both of the younger 2 being girls. So both of younger 2 must be girls, are girls. And if you look at this same listing above, well, there's 1 out of 4 situations there gives you both of the younger 2 being girls, so that's 1 out of 4. So now I can fill in these numbers here. Probability of A given B1 was 3/4. This probability is 1 out of 4, and that was also 3/4, just like below. So I can just write this in terms of numbers now. 3/4 times 1/2 over 3/4 times 1/2 plus 1/4 times 1/2. I see I've got a 1/2 everywhere. I can erase those if I multiply top and bottom by 2. And so that would give me, oh, you know what? I've got a 1/4 everywhere. So if I multiply top and bottom by 4 as well, that'll cancel away all my fourths. And then the top, that'll just leave me with a 3. And the bottom, that'll leave me with 3 plus a 1. I'm getting rid of all my denominators there. So I get 3 out of 4. And that's my final probability. So if I know that there are at least 2 girls in the family, the probability that the oldest child is a girl is 3/4. So let me recap that problem here. We're given that there are at least 2 girls, so that I'm going to set that up as my event A. We want to find the probability that the oldest child is a girl. So I set up one event for that, the oldest child being a girl. Oops, I see that I called that B1, and of course that should have been a B2. So let me change that. Probably get some good comments on this video saying, hey, you forgot to, you got the wrong B1 there. So I definitely should have made that be a B2. So B1 is that the oldest child is a girl, B2 is that the oldest child is a boy, and that divides my world into 2 complementary, 2 disjoint events. But the event of there being at least 2 girls, that overlaps both of them. And we want to find the probability that the oldest child is a girl given that there are at least 2 girls. So that's P of B1 given A. And then using my Bayes formula for 2 events, this is copied off the second slide of the lecture. You can go back and just look up this formula. That expands into A given B1 times B1, A given B1 times B1, A given B2 times B2. And I wanted to fill in those probabilities, and that's probably the trickiest part here. The probability of B1 is the probability that the oldest child is a girl. No problem, that's 1/2. And the probability that the oldest child is a boy is also 1/2. But now A given B1, that's a little trickier, and that's what I was working out here. That says, what's the probability of getting at least 2 girls given that the oldest child is a girl? So if the oldest child is guaranteed to be a girl, to get at least 2 girls, you have to get at least 1 girl in the next 2 children. So at least one of the younger 2 children must be a girl. And then I wrote out the possibilities. These are the younger 2 children that I wrote out here. The younger 2 children could be girl, boy, girl, girl, boy, girl, or boy, boy. And so how many of those have at least one of them being a girl? Well, there's 3 of those possibilities, so 3 out of 4. And that's where this 3/4 came from, and that's where this 3/4 came from. A given B2, this one right here. Now, that means that the probability of getting at least 2 girls, given that the oldest child is a boy. So if you want 2 girls and the oldest child is a boy, then both of the younger 2 must be girls in order to get 2 girls. And there's only one way to get that. That's right there. And so that's why we have a 1 out of 4 chance. And so that's where that 1/4 comes from. And so now we've put all the fractions in, and then it's just a simple matter of canceling away all the denominators. I multiplied by 2 over 2 to get rid of all the halves. I multiplied by 4 over 4 to get rid of all the fourths. Turned into 3 over 3 plus 1, which simplifies down to 3/4. So if we know that there are at least 2 girls, the probability that the oldest child is a girl is now 3/4. So that wraps up the lecture and the examples on Bayes' rule. It is a pretty complicated rule and it's very counterintuitive, so I strongly recommend using the formula for Bayes' rule even when it leads you to answers that might counteract your intuition. Certainly some of these answers seem kind of surprising to me, but the formula is guaranteed to be true, and so when you set things up right, you set up your disjoint events and you set up your overlapping event, then you can just kind of follow the formula after that and you'll get your answer. So this is the end of the lecture on Bayes' rule. This is part of the larger probability series here on Educator.com, and I am your teacher, Will Murray. So we'll be working through some more probability lectures. I hope you'll stick around for those,